Imagine you walk into a coffee shop. You order a latte. The barista doesn't freeze in place waiting for the milk to froth. They start your order, then take the next customer's order. And when your milk is ready, they come back and finish yours. That's exactly how async programming works in Python. And today, we're going to understand why Python needs it and how it works under the hood. Before async, Python had a problem called the GIL, the Global Interpreter Lock. Think of it as a single key to a shared room. Only one thread can hold the key at a time. So even if you have 4 threads running, only one is actually executing Python code at any moment. The rest are waiting outside. For CPU-heavy work, like number crunching, this is a real bottleneck. But here's the thing, most backend code isn't doing math. It's waiting. Waiting for a database. Waiting for an API. Waiting for a file to load. This is where async and await changes the game. Instead of blocking and waiting, an async function says, "Hey, I'm waiting for the database. Let me hand control back to the event loop so something else can run." The event loop is like a traffic controller, constantly checking what's ready to run next. You declare a function with async def. And whenever it needs to wait for something slow, you put await in front of it. The moment Python hits that await, it pauses that function, switches to the next ready task, and comes back when the result arrives. Let's look at a real example. Here's a sync function that fetches user data and order history one after the other. Each call blocks until it finishes. Total time, 4 seconds. Now here's the async version. Both calls run concurrently using Asyncio.gather. The event loop kicks off both at the same time, waits for both to complete, and returns both results together. Total time, 2 seconds. Same result. Half the time. That's the power of async, not faster code, but smarter use of waiting time. Now, the most common async mistake I see. Calling an async function without awaiting it. This is a silent bug. Python creates the coroutine object, but never actually runs it. Your database call never happens. No error is thrown. And you're debugging for an hour wondering why your data is always empty. Always await your async functions. And if you forget, Asyncio will warn you with a runtime warning, never ignore those. So to recap, the GIL limits true parallelism in Python threads. Async and await gives you cooperative concurrency on a single thread, perfect for I/O bound backend work. And the golden rule, always await your coroutines. Next episode, MongoDB. We'll break down aggregation pipelines, indexing strategies, and when to embed data versus reference it. See you in episode 2. If you found this helpful, hit like and subscribe, more episodes dropping every week.